ladies and gentlemen, straight from Italy for you, Laura Trotta.
Grazie. Grazie. And keep in mind, this presentation was prepared for like 30 minutes, but we have a bit more time. So if you at any moment want to interrupt me because something isn't clear or I'm going too fast, please do that, and I'll try to reply to the best of my abilities. So, welcome to Java RAG with SpringAI, Elasticsearch, and board games. We will get to the board games. As Piotr already introduced me, I am Laura Trotta. I'm from Italy. I'm a backend software engineer. In Elasticsearch, I maintain the Java client, and it's on GitHub. You can find me. You can come say hi, or maybe don't, because that's a new issue and it's more work. Disclaimer, I am not an AI expert, so my knowledge of what goes on underneath is average. I just work with it as a product. What we're going to do tonight is we are going to explain what RAG is and what it can do, what it can be useful for. We are seeing the tools that we're going to use to build a RAG application. And finally, we are going to build and hopefully run a Java RAG application. I did mention board games. So are you familiar with board games? Do you play them in your spare time? From time. But like, I think at least one game of Monopoly, everybody has played a game of Monopoly in their lives. Or like any variation of the game of the goose, which I learned that you don't have in Poland. I thought everybody has their game of the goose, which is basically like you throw dice and you go around and you do what the board says to do. Very simple games, minimal rules. You can set them up and play them with friends in 5 minutes. Now we're going to talk about the more complex ones, like Warhammer or Dungeons and Dragons, which you cannot even hope of setting them up in 5 minutes with friends, because the instruction manuals are actually like several thick books that you can fill all your shelves with. So I was thinking that what AI is very good at is that it can take a huge amount of content, text form, which, for example, can be a game manual, and easily extract information from it. So if you're looking for a specific rule or interaction between rules, instead of spending your afternoon looking into the manuals that you have, you could just potentially ask a chatbot. Turns out it's not easy. It doesn't work that well. I did try with Dungeons and Dragons, play the 5th edition. And what happens is the ChatGPT, I did try, basically, I mean, either hallucinates or it cannot distinguish between the edition, different manuals, the revisions. So it's and also sometimes it brings like a homebrew, which is user-created content, which is not official. It's a complete mess. I would like to continue with my Dungeons and Dragons example here, because it's my preferred use case, but the publisher, Wizard of the Coast, would send their lawyers at my home if I continue. So I'm going to use another board game, and this is Rune Wars. And I bet that none of you have ever played Rune Wars. And I'm correct, of course. It's a very niche game. This is the Edizione Italiana, Italian edition. Thank you. And it's a game where it's a simulation of fantasy warfare. So you have miniatures and you have to conquer enemy land and do some diplomacy, go through terrain, and defeat the opponent's armies. Same concept applies. So this is actually not a mousepad. This is the Rune Wars manual. And it's not Dungeons and Dragons size. It's 40 pages of manual. But same things. If I want to play a game, and last time I played was 3 years ago, I don't remember anything, I would like to ask for rules from an expert, which could be a chatbot. I did try that, ChatGPT. very simple question. Where do you place a reward card after obtaining it? And in Rune Wars, a reward card has to be secret. You have to put it underneath your hero card so that the other players cannot see it. And of course, ChatGPT says that it has to be easily visible on the board. So that's when it's wrong. Next one, which is even better. So as I said, you have miniatures, you go through the terrain. And there are such things as water terrains, which you can only cross with your flying units, or in the winter season of the war, which is a thing that happens, the water freezes, and so every unit can go through. Or third way, there are some special cards that you can use. ChatGPT, instead of suggesting any of these three, makes up the river trolls, which is a completely made-up type of unit that doesn't exist in the game or any of the expansions. I suspect it got this from some Warhammer expansion. I don't know. So with this, we've proven that ChatGPT doesn't know anything about Rune Wars. So how do we take this manual and ask an LLM to extract information from here? This is exactly what RAG is. So RAG, standing for Retrieval Augmented Generation, means taking your relevant data and adding it to the knowledge base of a language model. And what this does, other than giving it the information that you want, is it decreases significantly the chances of hallucination, because you explicitly say, just take the information from here and do not make anything up. So it will be most probably a precise answer. And of course, in this case, I'm using a game manual, but you can use whatever content you have. So it can be your company policy that you are never going to read and you want to get some information from it, or you're about to sign a user agreement and you want to check that you're not selling your soul to use a streaming service or something. So whatever you want. A little more detail on what RAG is, and this is kind of what we explained before. So step one, you take your additional documents and you encode them using an embedding model. This gives you the vector representation of the text documents. And in programmatic sense, the vector representation is like a list of an array of numbers. These get indexed in a vector database, which is a database specialized in handling vector representation. So now that you have all your data in the vector database, you can perform a query. And the query has to be encoded as well, using the same embedding model, so that, step 4, the vector database can perform the similarity search, which means comparing the vector representation of the query with the vector representation of the documents that it already holds. And step 5, what the vector database returns will be only the documents or the chunks of documents that it deems more similar to your query. So then you can combine the text representation of the similar documents with your query, and step 6, provide it to the LLM, which step 7 will provide a response. What are we using to build this architecture? So we're going to use SpringAI to build the application. And anyone used Spring in the last 2 years? I don't know. Anyone familiar with Spring? Oh, okay, that's more like it. Yes, for Java developers, so most likely I've worked with Spring. So SpringAI is the latest library from Spring, and it does what Spring do. So it adds a layer of abstraction over this plain Java code, making it super easy to connect with AI-related product, which is vector database and language models and embedding models and whatever. So as a vector database, we're going to use Elasticsearch, because of course, but If you know another vector database that it's better, of course, you can use it, and you can simply switch it in the application. In SpringAI, makes it super easy. I'm going to show you how to change the vector database. Another reason why I'm going to use Elasticsearch is that underneath, SpringAI uses the Elasticsearch Java client, which is the library that I maintain. Also, I helped writing the integration into SpringAI. So these are good reasons for me to use Elasticsearch. Lastly, as both embedding model and chat model, we are going to use OpenAI because I think it's the quickest to demo. Hoping to God that it works, because today it had an outage. The whole afternoon it was down. So let's hope, or as in Italy we do this. Now we'll see how the tools integrate with the RAG model. So our additional documents will be the Woundworks manual, this one here, in a PDF online form. Of course, I'm not going to use this. As vector database, we're going to use Elasticsearch, OpenAI as embedding model, and ChatGPT as LLM. Everything written in SpringAI. Now it is time for me to code the application. So you can scan this QR and it will bring you to the GitHub repo where the application is already coded and in a working state. I'll give you a few seconds to scan this, and then we're going to write it. There we go. So we're going to open our favorite IDE, and I have the skeleton ready, the blueprint, let's say, because otherwise it would have taken too much time. Yes. Was it Shift Escape? You know what?
Oh, yeah.
I think this is pretty visible. So we're using Maven as the dependency manager. So this is a Spring Boot application, so of course we need to import the Spring Boot starter parent. Then this is all information of the application. All of the dependencies that we're going to use from SpringAI are still in preview, so we need to add the Spring milestone repository to the POM to pull the dependencies from there. We're using Java 17. We need the SpringAI BOM as dependency management, otherwise it won't get, again, the dependencies. And now let's start with the actual dependencies. This one is Spring Boot, SpringAI, Spring Boot autoconfigures, which it provides a default implementation of all the services. So we won't need to create, for those familiar with Spring, the beans for anything, because it will be already provided, and we just need to configure them in the application properties. Then this is a dependency for the Elasticsearch integration as a vector store. This one is a PDF document reader that we're going to use to get the manual. And this is for OpenAI, both embedding and chat model. The properties, which are super small. Oh, let me see. I'm starting a local instance of Elasticsearch for this. You can easily start it. We have this new thing, it's called start local. And it's just basically a script that starts everything, the Elasticsearch server and Kibana. And once it's started, let me see. Okay, it's stopped. Okay. You can just check the environment. And of course, it's a local instance, so there will be the password in plain text, but just because it's local. And it will automatically pull the latest version. So I'll be using 8.16.0, which you can see it. Okay, so we need to add the properties here. first of all, OpenAI API key to connect to the OpenAI server, and the key I won't change here because I have it in my environment. This one is needed to enable the chat client, which otherwise won't reply. You have to enable it manually, otherwise it's not enabled. And now let's copy the properties from the locally running Elasticsearch instance. This is the default port. Username for local instances, it's always Elastic, and this is the password. And just to be super clear, these are the vector store properties. So this one here says tells Spring to set up an index, so it won't be created automatically, and it will be created before we start ingesting data. There are others, and I'm going to use another one. We are going to use a clean index. This is the vector dimensions, and this is, so it's this one, yes, index name. So today is December 12, and it's 1851, so you know that I'm not cheating with a pre-made index. We're going to do everything from scratch. And yeah, so as I was saying, basically, if you want to change both the vector store and the AI model, all you have to do is change the name here and the name here, and then you have to look up whatever properties you need. So you go to the SpringAI documentation and you check which are the correct properties, and this is all you need to do. The reg service that we're going to code will be basically the same. Let's go to the actual application. So this is a classic Spring Boot main. I'm not going to change this. This also is a simple REST controller, because we need just to interact with the application. So these are two post endpoints, which will take, this one will take a string to call the ingestion service to get the manual, and this will take the query to perform the actual query. The controller will use this rug service, which is what we are going to write. It is a service, of course, to initialize it to Spring. And so you see now it only needs a vector store and a chat client, and here it's explicitly declared as an Elasticsearch vector store, because I want to go inside and show you the inner workings of it. But as I said, it can be as generic as possible, and it could just be this. So we're not declaring any of the vector store or model, and it can be whatever. As I said, you switch the dependencies, you switch in the application properties, and that's it. But I want to show you how it works. So we're going to keep it as Elasticsearch for now. Right, so let's write the ingestion, and I'm quickly going to show you the manual, which is here. The publisher kindly keeps this online for everyone, so we're going to just use this. We can start with the PDF reader. So we'll create a new page PDF document reader, which will take the path. And this path here can be actually both a local path, if you have the PDF, whatever, downloaded, or a URL, and I'm just going to send it the URL. We'll read it, And this will output a list of documents, SpringAI documents. This will be our data. And if you go inside the document to see how it looks like, this will hold the text representation, so the actual content. The metadata depends on what you sent, so this will be set by the PDF reader. So in the case of a PDF, it will be, for example, the page number, and we're going to actually use that. This is the vector representation, which right now is empty, and it's going to be filled later. So we have our list of documents, and before sending them to the vector store, we are going to tokenize them. And what that means, it means we're going to split the documents in smaller chunks, because then the similarity search works better. Because of course, as I showed, it's better if you have like a smaller context, smaller possible context, yes. So by default, I'm going to use a simple one. We are using a token text splitter that just basically, what it does, it splits every 800 words or characters. I think words, yes. But there are more complex, like the semantic splitters that can understand, for example, when a paragraph ends and it can split there. But for the purpose of this demo, we don't need that kind of complexity. We will apply our list of data, and this will output another list of documents, which we are just going to put into the same one. Lastly, we take our vector store and we add the data to it. This is it. This is the whole ingestion. Of course, all the magic happens underneath. So we are not using explicitly any embedding model because the vector store has it inside. And what happens when we perform an addition is the embedding model is called to embed the documents, so the vector representation gets filled. And then these documents gets grouped and then bulk sent to Elasticsearch using the Elasticsearch Java client. This is basically it. Now, for the query part, we have this, which will be the user question. And we need to perform the similarity search. So we take our vector store and we do similarity search with a search request. The query will be the question. Now we'll set a couple parameters. Top K means how many documents we want the vector store to output. And in the case of a game manual, the same rule can be referenced in various pages or various parts of the pages, so I'm going to go with 5. Another parameter we're setting is the similarity threshold, which goes from 0 to 1, and it means how precise we want it to be. And we want the utmost precision, we just want rules, so the precision will be maximum, which is 0. This is the similarity search. It will output, you can guess, a list of documents. And this list of documents will be our relevant data. Now we take our relevant data, which will be up to 5 documents, and we put, compress them in a string representation. So it will be like a string context. It will be the relevant data. We do a stream, we do a map. We get only the content of the document. We collect them, separate with a comma, and that's the context. So now we take our prompt, because we need to give instructions. to the model. And the prompt says, you're assisting with providing rules of the tabletop game Rule Wars. Use the information from the document section to provide accurate answers to the question in the question section. If unsure, simply state that you don't know. So the documents will be our context, and the question is going to be the user question, which is this one. There we go. This is sent to the chat client. So the chat client will do a prompt.user and will insert the prompt. And oh, this is going to be a string. It's a string answer. User prompt will call the model and get the content. Now we could just output the model answer, but as I said, it's a PDF. We know the page number, and we can use the page number to verify if the information is actually correct. So what we're going to do is we're going to take the metadata of the first document from the list, or we could do, like we could also take the other page numbers, but usually one page is enough. So what we will return is, yes, answer plus found at page. And now we're getting the page. The page will be the relevant data, as I said, the first one for simplicity. We'll get in the metadata. And the key for the page number is set by the page PDF document reader. It has a constant, which is the page number, plus of the manual. We're done. This is the whole application. Now we're going to run it and hope. The Spring logo is always reassuring. And let's open, we can call it simply with Searle. It's big enough. I think so, yes. And I don't remember Searle by memory, so I'm going to take something from my cheat sheet. So we're calling the first endpoint in the controller, the one, the first one. And this is just the PDF manual. So we can see it will start processing it, yes. So this is just the PDF reader downloading and processing the pages. This is the text splitter, which is splitting the bigger pages into chunks. And when it says that it's done, it's done. What we can do now is we can go into Kibana. And I think I already have the password right. And does this have a dark theme, Kibana? Do you know?
Let's stick with this one. I don't know, either way.
Okay. So this was the default one. And what did I call the index? I called it as the date. What we can do is we can pick in the vector representation, so what actually get indexed into Elasticsearch. So this is a classic blueprint of an index, and here it is. This is the embedding, and look how big the vector is. This is probably half a page or something, and yeah, I wanted to also see some text. It will be, yeah. This is this is the lore that is in the beginning. You can see thrice have great wars ruined the land of our forefathers, And this is the computer version of it. So this is what goes on inside. And now we can perform an actual query. So nope. We'll get our other serial call. And let's start with my favorite one, which was the water border thing with the river trolls. So we're going to ask, is there any way a unit can cross a water border? And let's see how it performs with having the actual manuals. So it says there are a few ways unit can cross a water blue border in Rune Wars, flying figures, when it's winter, borders are ignored, and special cards. This is accurate, and it also says that it's found at page 18 of the manual, and you can actually go and check. And it will have the information on movement restriction, specifically water borders. We can also try with the other one, which was the reward cards. And we'll ask it, where do you put a reward card after obtaining it? And it will say, interrupt part that looks at it and place it face down under the hero card of the hero who received it, found at page 27 of the manual. You can go check. And there it is, information on reward cards. So this works nicely. And I'm going to also show you another another case that I found interesting. So this goes a bit, it changes a bit the concept of reg, because we are now going to feed it the whole manual. So how do we do that? We say that top K is 1,000. So it will basically retrieve the whole thing, and we're going to change the prompt. And the prompt will be, you are assisting with analyzing the game Rune Wars before it gets published. The manual will be in the documents section. Use it to answer the question in the question section. Okay, we don't have to ingest anything. It has the manual already, so we'll just start it. And what we can ask it is, we can do I hate this so much. We can do something like this and ask it, can you find any discrepancy in the rules of the game? And now what it will do, it will analyze the whole content of the manual and actually look for problems in the rules. So it's a long one, and it says that there are some potential discrepancies or points of confusion, and we probably, we would have to know the rules by memory to know if it's right. But it's surely interesting that it can analyze the whole manual and provide what it thinks it's confusion, or things that are not written very well for players to understand. Am I on time? Can I do one last thing? Okay. Just one last thing. So this method here, the query one, it could have been even shorter. I have to use the vector store explicitly because I really wanted the page number to do the double check thing. But SpringAI has a tool that is called Question Answer Advisor. And what it does is it simplifies this even more because you can just configure it. There it is. Oh, I don't have the shortcuts to do this. So you take this is it, the question advisor. You can pass it the vector store, and you can configure to also hold like the chatbot memory, which is a thing we didn't do because we didn't care. But if you want like a full ChatGPT-like experience with memory, you can do it like this, and so the method would have been just this, configuring the chat client with the memory and the question answer advisor, and just prompting it with this configuration here. Thank you. This was it. You find here is a QR code to give me feedback for this presentation, because I'm kind of new to this presenting thing, so any feedback helps, and I'll be very grateful for it.